This video is brought to you by us, RealPARs. Join the top 1% of PLC programmers. Learn from the world's best so you can join their rank. Head on over to realpars.com and start learning now. In this video, we're going to show you how to wire a thermocouple to a PLC analog input module. We're also going to discuss thermocouple cold junction compensation and challenges when working with extension wires. Okay, let's kick things off with a quick review of what a thermocouple is. A thermocouple is made up of two dissimilar metal wires. These two dissimilar metals are joined together at one end and open at the other end. The joined end is called the measurement junction. Heat applied to the measurement junction will produce a voltage across the open end. As the applied heat increases, so does the open-ended voltage. Thermocouple manufacturers have purposely chosen metal wire pairs that produce 0 volts at 0 degrees Celsius. Certain wire pairs have become popular as industry standards and assign letters to indicate their type. For example, a Type K thermocouple is made from alloys chromel and alumel. Thermocouple tables have been produced listing the resulting voltage at specific temperature values. Well, if we want to make a temperature reading, it seems easy enough. All we need to do is measure the open-end voltage. Unfortunately, it isn't that easy. First of all, the voltages produced are very small, and the actual change in voltage per degree Celsius is minuscule. Secondly, as soon as you connect a measuring device to the open end, you create more junctions that create unwanted voltages. All right, let's connect a thermocouple to a PLC input module. Most PLC vendors offer thermocouple modules. These specially designed analog modules provide what's referred to as Cold Junction Compensation that eliminates the effect of any new junctions created. Let's take a closer look at a typical thermocouple module. The Siemens 6ES7 531-7PF00-0AB0 is an analog input module capable of connecting 8 thermocouples. This particular module offers several options for providing cold junction compensation. Why are there different options? Well, for one reason, the cold junction can be at different locations depending upon the application and the location of the thermocouple. Keep in mind that anytime a thermocouple wire is connected to a different material, a new junction is created. We'll talk more about that later. The Siemens Thermocouple Module Manual shows all the possible compensation options available. Let's look at an application where the thermocouple is connected directly to one of the module inputs. In this example, we're wiring a Type K thermocouple to terminals 3 and 4 of the module. The positive yellow insulated wire is connected to terminal 3. The negative red insulated wire is connected to terminal 4. As a rule of thumb, thermocouple wires with red insulation are negative. Here are examples of 3 typical thermocouples. Note that all of the negative wires are insulated red. In this wiring scenario, the cold junction is right at the terminals of the analog module. The module has an internal sensor that can compensate for the cold junction. The thermocouple type and the source of cold junction compensation are configured in the Siemens Step 7 software program. Let's move on to a different scenario. What if the thermocouple was located at a distance from the PLC? In this scenario, you can use the thermocouple extension wire because using standard copper wire creates new junctions and unwanted voltages. A thermocouple extension wire is made of the same material as the thermocouple, thereby eliminating any possible new junctions. Using thermocouple termination blocks will ensure that new junctions are not created. With thermocouple extension wires, the cold junction is at the terminals of the analog module, and therefore the module can be configured as in our first scenario. We've just described 2 possible wiring scenarios out of many. If you aren't sure if your wiring option is possible, your best resource is the manual for your module. As we said earlier, all compensation options and wiring diagrams are specified in the module's manual. If you want to learn more, you might want to review our other videos called Thermocouple Explained, Working Principle, What is a Temperature Sensor, and Temperature Transmitter Explained, Connection and Calibration. You can find the link to these videos in the description. Okay, let's summarize what we've discussed. A thermocouple is made up of two dissimilar metal wires joined together at one end and open at the other end. The joined end is called the measurement junction. Heat applied to the measurement junction will produce a voltage across the open end. Thermocouple tables have been produced listing the resulting voltage at specific temperature values. Connecting a measuring device to the open end creates more junctions and unwanted voltages. Most PLC vendors offer thermocouple modules, providing several options for cold junction compensation. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.